Physics Part 253. If you go to Earth radii from the Earth's surface, the force is quarter of the force on the Earth's surface. This is part of Newton's law of gravitation. Newton's law of gravitation states that two points' masses attract each other with a force that is proportional to the product of their masses and inversely proportional to the square of their separation. Hence, if F is a force of attraction between two bodies of mass m1 and m2 respectively with the distance r between their centers, the F into m1 m2 over r square, or F is equal to g m1 m2 divided by r2, where the constant proportionality is g, which is called the gravitational constant. The value of g is 6.67 into 10 power raised to minus 11 Newton meter per kilogram. Notice that the equation has a similar form to that of the Coulomb's law between two charges. Both Newton's law and Coulomb's law are inverse square laws of force. We say that the equations are analogous, and there is an analogy between these aspects of electric fields and gravitational fields. However, there are important differences. The electricity force acts on charges, whereas the gravitational force acts on masses. The electric force can be attractive or repulsive depending on the signs of interacting charges, where two masses always attract each other. It is possible to measure the gravitational constant G in a school laboratory, but the force of gravity between the laboratory-sized masses is so small that it is not easy to obtain an accurate result. Gravitational field strength. The gravitational field strength at a point is defined as the force per unit mass acting on a small mass placed at that point. This continues the analogy between the electric and gravitational fields. Remember that electric field strength is defined as the force per unit positive charge. The force per unit mass is also a measure of the acceleration of free fall by Newton's second law of motion, F is equal to ma. Thus, the gravitational field strength is given by F over m is equal to g, where F is in Newton and m is in where F is in newtons and m is in kilograms. This means that the gravitational field strength of the Earth's surface is about 9.8 n per kilogram. The unit n kilogram is equivalent to the unit of acceleration, meter per second. Remember that we had two equivalent units for electric field strength, Newton per c and Vm. Although there is a clear analogy between nkg and nc, there is no direct link between meter per second and volt per meter. Field strength due to an isolated point mass. We have already met the idea of a point mass in talking about the motion of a particle. Of course, all the masses we come across in the laboratory have a finite size, but for calculations involve gravitational forces, it is fortunate that a spherical mass behaves as if it were a point mass at the center of the sphere, with all the mass of the sphere concentrated at that point. This is very similar to the idea that the charge on a conducting sphere can be considered to be concentrated at the center of the sphere. The gravitational field outside a spherical mass is a radical one, just as the field associated where the point charge is radial.